So in this video, we're going to look at an integral involving partial fraction decomposition. Now, one of the first things you want to look at when doing these is you want the degree of the top polynomial to be less than the degree of the denominator polynomial. And as you can see, the degree of the numerator is 4 and the degree of the denominator is 2. So this tells us the very first thing we're going to have to do is we're going to have to do long division of polynomials. So let's get right into it. We've got x squared plus x minus 2 divides x to the 4 plus x cubed plus x squared plus 1. All right, so we're going to have x squared giving us x to the 4 plus x cubed minus 2x squared. We're going to subtract that off. So we get rid of our x to the 4. We get rid of our x to the cubes. That gives us a negative and negative, gives us a positive. So we get 3x squared, and then we bring down our 1. Now, what we can do to get rid of our 3x squared is we can add a 3 up here. Multiply that out. That gives us 3x squared plus 3x minus 6. We're going to subtract that off. So our 3x squares cancel. And then we're left with a negative 3x and negative 6, or 1 minus a negative 6 gives us positive 7. And that's our remainder. So what we're going to do now is we're going to rewrite our integral to look like this. We have x squared plus 3 plus our negative 3x plus 7 over x squared plus x minus 2. All of this is our integral. Don't forget your dx. Okay, now what we need to do is we need to factor out our denominator. So when we factor that out, let's just bring all this over here. We end up with negative 3x plus 7 over x plus 2, x minus 1. In partial fraction decomposition, we've got our a plus our b. And our a is over x plus 2. And our b is over x minus 1. Okay. So at this point, we want to get rid of our denominators. We don't want anything on the denominator, so we want to multiply both sides by our common denominator, which would be x plus 2, x minus 1. If we do that on the left side, we're left with just negative 3x plus 7. If we do that on our right side, well, our x plus 2 would cancel out with a, leaving us our x minus 1. So we have a x minus 1 plus b, and our x minus 1s would cancel here, leaving us with an x plus 2, like that. So in this case, we can just kind of guess what our numbers would be that would get us our a's and b's. So for our first guess, let's go with x equals 1. All right, so when x equals 1, we have negative 3 times 1 plus 7 equals, well, if we put in a 1 here, 1 minus 1 is 0, so our a cancels out, leaving us with b times 1 plus 2, which we have negative 3 times 1 plus 7 gives us 4, and that equals 3b. So b equals 4 over 3. Okay? Now let's say we have x equals negative 2, so we can cancel out our b term over here. So we get x equals negative 2 So now we have -3 times -2 plus 7 equals a times -2 minus 1, and our b term cancels. So -3 times -2 is a positive 6, plus 7 gives you 13, equals -3a. So that gives us a equals -13/3. That is our a term. So now we're going to plug our a term and our b term in over in our integral. So we're going to write integral of x squared plus 3 plus, well, our a term is -13/3, and our a term was over x plus 2. Plus our b term, which is 4/3, and our b term was over x minus 1. Like that. So the first thing I'm going to do is I'm going to rewrite this, pulling out our fractions in front of these. So what we end up with is the integral of x squared plus 3 minus 13/3 times 1 over x plus 2 plus 4/3 times 1 over x minus 1 dx. All right, now from here, we're just going to integrate. Our x squared term becomes x cubed over 3. Our 3 becomes 3x. Now we have -13/3. Well, 1 over x plus 2, that's going to become the natural log of x plus 2. Then we got plus 4/3. 1 over x minus 1 is going to become the natural log of x minus 1 plus our constant. Don't forget your plus c when you're doing an indefinite integral. So that's how you do a integration involving partial fraction decomposition that also involves long division of polynomials. So I hope you enjoyed this video, and I will see you next time.